Okay, so yesterday we talked about the state and the plan portion, and today we're going to talk about the do and the conclude. Okay, and just as a refresher, you already have this, in your notes. Your expected counts were all 20. Okay, because we assume that each day of the week should have the same number of births. That was what we were actually trying to prove, that the distribution that they told us, that it would be the same across all the days of the week. Okay, so we already did our null and we already did our alternative. And the null was that, let's see, what was it? It was the distribution is as stated, the births are evenly distributed throughout the week. And the ha was at least one day is not proportionally equal to the rest, or something like that, okay? And we did conditions, with the random being, or not random, rather, our normal now being all our expected counts are bigger than 5. So now we do the do. Okay, so we're going to start by doing this by hand, okay? And it is observed minus expected squared divided by 2. Right, I do believe it is observed minus expected because I can trying to remember which way the formula goes. 10%. Yes, observed minus expected. Okay, never remember which one goes first. And then we have to do this 7 times, and we have to add them all together. Okay, it's not difficult. I know you did this if you were in biology, or you should have. So, just to start it out, as far as the setup, so 13 minus 20 squared, and that's supposed to be divided by expected, not divided by 2, divided by expected, which would be 20. All right, plus 23 minus 20 squared divided by 20, plus 24 minus 20 squared divided by 20. We're going to have a 0 one. 20 minus 20 squared divided by 20, plus 27 minus 20 squared divided by 20, plus 18 minus 20 squared divided by 20, and then the last one, 15 minus 20 squared divided by 20. Okay, and what's going to basically end up happening, there's a reason these are all being squared, because if they didn't, it would end up working out like when we had our standard deviation. Why do we square everything? Because otherwise it ends up being 0, because basically half are above and half are below on average. Okay, so let's see, 13 minus 20 squared is 49. So 49 over 20, and I'm just going to go ahead and leave it as a fraction for right now so I can do this by hand. And again, we square it and everything comes out positive anyway. So that's 9 over 20. Let's move those down here so I can add them all together. And I'm sure you can do this much, much faster in your calculator, but remember, I don't have mine. 16 over 20 plus 0 plus another 49 over 20. Let's see, plus 4 over 20 plus 25 over 20. Okay, so add those all together. That's 58, 68, 74. Ooh, I'm going to cheat. 78, 98, 103, and 143, 152. So 152 over 20, and now I'm actually going to grab my calculator and divide that. And again, you do this in your calculator, I'm sure it will come out much faster, and you should still end up getting the same answer, I hope. That should be 7.6. Okay, so this is our, basically this is our chi value, sort of like a t value or a z value. This is our chi square. Okay, that is our chi-square statistic. Now we talked, what's today, Friday? We talked Wednesday about degrees of freedom. Okay, and degrees of freedom is one less than however many groups you split your population into. This has been split up into 7 groups, so my degrees of freedom is 6. So I need to go to my chi-square table, and I need to try and find whatever's closest to 7.6 at 6 degrees of freedom. Okay, so we're going to do this just like we looked up a t-table. We're going to find the value that's closest to it, and then we're going to look above and get our p-value, our actual p-value from it. So flip to the back of the book and get to the chi-square. Here we go. 6 degrees of freedom. 7.6 is to the left of the graph, right? It's off the chart to the left, okay? Which means your p-value is basically bigger than 0.25. Okay, so p is greater than 0.25. Now, when we're doing this, and it didn't give us a choice, so we're going to go ahead and still compare to alpha equaling 0.05, because this really is an inference test. This is greater than alpha equaling 0.05. Don't forget to have your comparison in there, otherwise you lose points. So now, how do we state our conclusion? Well, the conclusion is pretty much stated the same way your alternative and your null hypothesis is. The same way it's always been. Okay, so if your p-value is 0.25, and this is something that some of you are still getting stuck on, and we're going to, talk about this one in depth more when I get back about why you're still getting this backwards. Okay, so conclude. We are going to fail to reject. Okay, that means we are failing to reject the null, right? And if we're failing to reject the null, no, we don't actually accept the null. But if we're failing to reject the null, it's because we don't have enough evidence to conclude that the alternative has to be right. And what is the alternative in this case? To conclude that at least one day of the week does not have equal births. That is pretty much how we wrote the alternative yesterday. And that's how we write it. You literally go back to your alternative like you're supposed to. But looking up on your chi-square table, again, is like looking up on your t-table. You go to your degrees of freedom, you try to find the thing that's closest to your value. Okay, like I said, by now it should be like you're having nightmares about doing four-step process. Okay, and the only thing I said we were going to do today was finishing off the two problems that you started yesterday. Okay, now this one's even shorter as far as that goes because, again, we have our null and our alternative from yesterday, and the distribution was 25% green, 50% yellow-green, and 25% yellow. And then the alternative, at least one proportion is incorrect or is not as stated. Okay, but the very important part is the at least one, because we don't know one or more or all of them. We have to say at least one. Okay, so we had our expected counts, right, because these are our observed. This was supposed to be, let me do this in a better color. This was supposed to be 21, right? That's 25% of 84. This was supposed to be 42. And this one was also supposed to be 21. Okay, so yeah, 1/4, 1/4, and basically 1/2. So we're going to, again, do the do. Observed minus expected squared divided by expected. All right, and since we've only got 4, again, hopefully this won't take very long, but you should be typing this into your calculator to check it. So let's see, 23 minus 21 squared divided by 21 plus 50 minus 42 divided by 42 plus, let's see, observed minus expected divided by expected. Okay. So all grand total, that would be, what is that, 4 over 21? 12, right? No, that's 8. 50 minus 42. Wow. 64 over 42 plus, oh, that's going to be 100, right? 100 over 21. And again, I'm sure you've got this much, much faster in your calculator. I'm just going to go ahead and add them up. That would be 872. 272 out of 42. Okay, so again, 6.48 is what I'm getting rounded. I think that's right. Yep, 6.48. Okay, same thing. Go to your chi-square table either in the back of your book or in your formula sheet. And we're looking at 2 degrees of freedom. Very, very small because, there's only 3 groups in the whole set. So, okay, 2 degrees of freedom, right? That's what you're looking for. And if you go, that's going to go pretty good ways across to find 6.48. So let's see. The way I'm getting it, it looks like my p-value is between 0.05 and 0.025. Okay, so if you remember, this is how we were writing it before because it happened to be between those 2 p-values. That is actually less than our alpha of 0.05. All right, so here's the thing. And by the way, we use 0.05 because when you do this in your calculator, it automatically does it at a 0.05 rate. Okay, so, and we'll talk about how to put this in the calculator. It's very, very easy. Okay, so that is less than 0.05. So we have something very specific that we have to do when we write our conclusion. We have to talk about our biggest contributor. And I talked a little bit about that yesterday, about how a contributor is basically each of these individual pieces. Well, which one caused the, basically which one caused you to end up rejecting the null? Which one was so far off that it made your chi-square statistic so big? Okay, because the bigger this gets, the bigger the chi-square, that means the larger the differences between what should have been and what you actually see. So we have to go back and look at the one that was the farthest off. So our conclusion in this case, because our p-value is so small, is that we are going to reject the null. If we reject the null, it means we have enough evidence that the alternative is correct. Okay, so we have enough evidence to conclude that at least one of the proportions is incorrect, or not as stated, or something to that effect, but at least one is the important part. Okay, so now we have to give the biggest contributor. Well, if you take a look at your observed and your expected values, which one was the furthest away? Yeah, yellow. Okay, so this is how we have to state it. Yellow was the biggest contributor. Now, we have to give a direction. Did it have more or less than expected? Because it won't matter in the long run when you're talking about your chi-square value. Being above or below your expected count is going to cause your chi-square value to go up either way. So yellow was the biggest contributor with 10 less than it should have had, or 10 less than expected. There we go. There were 10 less of the yellow plants when they crossed them than they expected to get. They expected to get 21, they only got 11. Okay, and that is how you have to put the extra phrase in there for chi-square. And you're going to do this, it doesn't matter, there's 3 different chi-square tests we're going to run. All 3 of them are required for you to do this only if you reject the null. Basically, what caused you to actually come up with enough evidence? If you have two things that are tied, then you can list both if they're the biggest. If it's only one, then you just list the one. Okay, and that is it. Over the break, I want you to continue reading chapter 11. Oh, real quick. There we go. In the calculator, you go to stat tests, and it literally has chi-square GOF, and then it has just a chi-square test underneath of that. Please remember, we're doing a goodness of fit. Okay, here's where the data has to go. You go into your lists, like where we would put our data if we're going to, do a histogram, or if we were going to graph it like linear. Okay, so you put your observed data in L1 and your expected data in L2. And if you go to the GOF test in your calculator, it's going to ask you where is your observed and where is your expected. Okay? And here's the thing. When you actually run the test, okay, do you remember how when we were doing linear regression, I hope you remember, when we were doing linear regression, I know it's been a while, chapter 3, when we ran the actual linear regression, the residuals were automatically stored in a list for you. Okay, the same thing is happening here. When you run a GOF test, you can go back into your second list menu and you can scroll down and you will see CNTRB, and those are called contributions. And you can actually take a look at it and it'll give you the chi-square statistic, each piece, right, little chi-square, for each one of your values of your observed and expected. It's basically doing this for you, and it's listing them all individually. Okay? But it'll give you the chi-square total. It'll give you the p-value when you run it in your calculator. Now, that being said, tonight, or sometime rather, this weekend, what I had you do last night, I think was 1, 2, 5, and 6 maybe? And that was like 5A and 6A. I want to make sure that I'm not overlapping here, because you should actually be able to finish those two problems now, because I believe the next part of the problem was to actually carry out the test. All right, so let's take a look. Let's see. Yeah, 1, 2, and then, 5 and 6. Okay, so basically, I don't want you to draw the graph. Okay, so it's actually, you know what, let's fix this. So what you're going to be doing today is number 3, number 4, you're getting the actual statistic. Let's see, and then you're going to do 5 C and D, 6 C and D, and you can, tack these with the other problems that you've been doing, so you can, get them back in there. And then I want you to do number 12, so don't worry about 13. So 3, 4, 5 C and D, 6 C and D, and number 12. And this will be your second set of chapter homework for this section. Okay, and I want you to continue reading chapter 11 and looking at the notes in Canvas. Other than that, have a good spring break. Come back hopefully well rested. And I hope none of you are planning on skipping the Monday when you come back from spring break, because, we have way too much to do, especially if you want to start reviewing for the AP exam. All right, take it easy.